In this video, we'll talk about how to assign oxidation numbers. Now, there are some rules that have to be memorized when assigning oxidation numbers, and the rules are right here. There are basically two criteria. We have free elements, so just think of them as elements. Whenever you have an element alone, it doesn't matter if it's a single atom like monoatomic sodium or diatomic chlorine or polyatomic sulfur. Since they are elements, meaning there's no second different element connected to them, then their oxidation states are all zero. That's the most important rule. Now, the rest of the rules that I have here in orange, they are for compounds. Now, when you have group 1 elements in a compound, so remember group 1 is from lithium straight down. I'll show you those. So group 1 is going to be from lithium straight down. They are all +1. Group 2 is from Be straight down. They are all +2. And then the other three elements that have rules are going to be F, H, and O. Those rules are just for those unique elements, and then no other elements have rules. And then again, they have to be in compounds to have those rules. If any of these things happen to be alone and in the elemental form, then they're considered elements and they have a 0. Now, these rules do have to be memorized, and they work off of the concept of conservation of charge. Basically, the individual charges of the atoms have to add up to equal the total charge of the compound. That pretty much should make sense to everybody. It shouldn't be a big deal. So now there are really 4 scenarios that we're going to work on. So the first scenario are regular compounds. So if you notice, these compounds don't have charge. And the reason I know they don't have charge is because if I look at the top right-hand corner, there's nothing written there. So the charge, if it's not written, would be 0. So I'm not going to write the 0 in, but these things have a total of 0. That's their charge total. So the sum of the individual elements is going to have to add up to equal 0 in these cases. Now, the way you do this is pretty simple. You figure out which elements have a rule. So in this case, sodium is in group 1. Group 1 has a rule, it's +1. Nitrogen does not. So nitrogen I'm going to have to figure out on my own, but I'm going to stop here and do the rest. In this element, F has a rule, it's -1, or compound. In this compound, oxygen has a rule, it's -2. And in this compound, you have 2 rules. We have a rule for O, it's -2, and we have a rule for Ca, it's in group 2, so it is +2. Now, the way you do it is we are going to figure out the sum of the individual elements. So sodium is +1, but there are 3 of them. So the way I like to say it is I say multiply down and add across. So 3 + 1 is going to give me +3. Now I need to figure out what nitrogen needs to be to make this equal 0. So down here at the bottom, I know it's got to be -3. Since there's only 1 nitrogen here, the reason I know there's only one, is that there's no number written. So the assumption is that there's 1 of them if they don't write the number. Then my 1 nitrogen has to give me all the -3. So that way I can make this equal 0. Next one. There's 2 Fs. They're -1 each. So if I multiply down, I get -2 from F. So mathematically, Fe has to give me +2 to make it equal 0. There is only one Fe, so it gets the whole +2. You'll see on the next one where it starts to make a little bit more sense, hopefully. So there are 3 O's. They are -2 each. So if I have 3 -2's, I multiply them together, I get -6. Now I know that aluminum has to give me +6 to make it equal 0. But there are 2 of them. So they're not going to be +6 each, because that wouldn't give me +6, that would give me +12. So they are actually +3 each, because +3 times the fact that there are 2 of them will total +6, which is what I ultimately need. Next one. Multiply down, I get -8 from oxygen, because 4 -2's. There's 1 calcium, that gives me +2. So now if I do the math on this, remember, here's what I'm looking for. I'm looking for 8 - 8 equals 0. 2 of that 8 comes from calcium, so the remaining +6 has to come from chromium. So since there's only 1 chromium, it gets the whole +6. If there was a 2 here, then they would be +3 each. Hopefully you get the idea. And that's how you do standard compounds. Now, ions are done basically the same way. The only difference is ions have charge written in. So if you look at these 3 examples, there's a negative here. What that really means is -1. They don't write the 1 when they write charges. It's just how it's done. You can write, I want you to write it in, but you'll never see it written that way, or you'll very rarely see it written that way in a textbook. Plus means +1, And 2 minus, although it's weird to think of it like that, we don't normally say 2 minus, we would just say minus 2. It's fine either way, it doesn't make a difference. And so the way we're going to do it is, instead of setting them equal to 0 like I did in the compounds, I'm going to set them equal to the charge total. Okay, so -1 + 1, -2. So do not confuse it. These charges, the common mistake I see a lot is people think, or students think, that the charge is for this negative is for the O, that this positive is for the H, and that this -2 is for the O. It's not. It's the total on the compound. They almost never will write in the individual oxidation state numbers. So now I'm going to do the problem. So I have a rule for O. O on its own is -2. So -2 times 3 gives me -6. So now I do the math. It's got to be +5 minus 6 to give me -1. It's the same type of problem now. I'm just, instead of going for 0, I'm going for a charge. So since there's 1 chlorine, it gets the whole +5. Here I have the rule for H is +1. There's 4 of them, so that gives me +4. So therefore my nitrogen has to be -3, so that my total is +1. There's only 1 nitrogen. It's not written, so it gets the entire -3. Next one, there's a rule for O, it's -2. There's 7 of them, so that gives me -14. My chromium is going to have to total +12 to make this work mathematically. Since there are 2 of them, they are +6 each. So the rules are no different. The only difference between an ion and a compound in this case is what you're setting them equal to, and you have to be aware that the charges are not for any one element, they are the sum of the whole thing. It's better to write them like this with parentheses and the charge outside. This is what it really means, but it will never be written that way. They just don't do it. They assume that you know enough to know that if they're putting a charge in, that it's for the total, not for any one specific element. Next one, exceptions. So there are exceptions to the rule, and the way you know that you're dealing with an exception is pretty simple. The math doesn't work. So if the math doesn't work out, this is how you know you're dealing with an exception. I'll do one where the math doesn't work, and then I'll show you how to fix it. So the example would be here. There's no charge, so we're going to set it equal to 0. We're actually going to do that for all of them because they don't have any charge written in. Exceptions most likely are not going to have a charge, but in reality, you could have an exception with a charge. In this case, it doesn't. So there's a rule for Na. It's group 1. It's +1. There's a rule for H. It's +1. So there's no way that this can possibly equal 0, because +1 and +1 does not equal 0, it equals 2. This is how you know you're dealing with an exception, because you followed all the rules and the math doesn't work out, something's wrong. So here's what we're going to do. We are going to break one of the rules. The rules are listed in order of importance as well. So meaning rule 1 is the most important, it cannot be broken. Rule 2 is the second most, and it cannot be broken by any rule below 2. And so you get the idea. So the rule for sodium is rule 2, and the rule for H is rule 5. So H's rule is less important, so guess what I do to H? I completely forget that H has a rule. And now I make H whatever it needs to be to make the math work. So in this case, to make this math work, H needs to be -1, so I make H -1. It's that simple. The same thing for this problem. Calcium's rule is more important, so I keep it. H would be +1, which would give me +2, and obviously it won't equal 0. So H has to do the same thing. It has to change to -1, so I get -2. The other ones, same deal. I would have a rule +1 and -2 here, and I would have -2 and -1. Those are the rules. So mathematically, I would get this. +2, -4, -2, -2. And again, these don't equal 0, and that's how I know I'm dealing with an exception. So I go to the list and I say which rule is more important. For H2O2, H is more important, so the rule for O completely goes away. I'm not erasing the negative sign because I already know it's got to be negative, but in this case it has to be -1, so that way when I multiply down I get -2 to make the math work. In this one, the rule for F is more important than the rule for O, so O has to totally change to make this math work. So I end up with +2, I should do it in red. So I end up with +2, so that way I get +2 -2. That's how you deal with exceptions. The last thing we are going to do is how to do polyatomic ions. So now, Polyatomic ions are found on table E. And basically, they have charge. And so what you're going to do is you can go to table E and look them up. So here's the polyatomic ion table. The charges are written there, so that makes life easy. But these are a little bit different. The problem here, okay, is that I don't have a rule for copper, I don't have a rule for S, and I only have a rule for O. So the only thing I have a rule for is oxygen in this case. Actually, in all cases, in all three of these examples, oxygen is the only thing that I have a rule for. And so I wouldn't be able to do the problem because I have two unknowns. It's like math. It's like saying x plus y equals 5. If you can't define x or y separately, then you can't solve the equation. So here's the trick to doing these problems. If I go to table E and I find the polyatomic ion, like for example, SO4 when it's alone, if I look it up here, it's right here if you can see it, it has a charge of -2. So when SO4 is alone, it's -2. So what I'm going to do is I'm going to treat it like it's an ion. So the way I do that, set it equal to -2. I have a rule for oxygen. I multiply down, I get -8. So mathematically, sulfur has to be +6. So therefore, I get +6 because there's only one of them. And now I solve for SO4. So this is just like an irregular ion. Here's the trick. Now that I know that the S in SO4 is +6, turns out the S in every SO4 ever is always going to be +6. So I can plug it in there, and I just got rid of one of the two variables. So now I can go back and do this problem like normal, set it equal to 0, and solve for copper. So the way I do that, I multiply down, that gives me -8. I have one S, it's +6, and then mathematically I need copper to be +2, so that way I get 8 minus 8. And since there's only one copper, it gets the whole +2. That's all you do. Let's try another one. Again, same thing, two variables, I don't know N, I don't know Fe. But if I look at NO3 on the polyatomic ion table, NO3, it says it's negative, which means -1. So set NO3 equal to -1. I have a rule for O, it's -2. Multiply it down, I get -6. So N has to be +5 to make that work. And since there's only one N, it gets the whole +5. Now, I'm going to take the +5 from N and put it in here. Do not worry about this 2 outside, the parentheses. All this is telling me is that I have two NO3s, but each NO3 is still going to have these numbers. I'm just going to have double the amount of them. So watch how I do that. This is a little different. When I set this whole thing, when I solve for this problem, I'm going to set the whole thing equal to 0. Okay? The 2 outside the parentheses is going to distribute to both the N and the O. There is an unwritten 1 there. And so instead of 1 N and 3 O's, I'm going to have 2 N and 6 O's. So that's all this 2 does. It does not affect the Fe because the Fe is not in the parentheses. So instead of -2 times 3 would give me -6, I multiply it by 2 again and I get -12 from oxygen. I'll then get +10 from nitrogen, and so mathematically I need +2 from the iron to make this whole thing equal 0. Since there's only one iron in this equation, it gets the whole +2. Last one, and then we are done. So I have -2 for O. There's 4 of them. I don't know P and I don't know V, so I have to do it the same way. I look up PO4 on table E. It's -3. Set the whole thing equal to -3. I have a rule for O. I get -8 from the O. So I'm going to need +5 from the P. That means the +5 goes there. So I put it in here, just write it in. Again, I'm ignoring this at this step because I'm just worried about the P and PO4. There happen to be 2 of them, so now that distributes. So I set the whole thing equal to 0, and it's really -16 because there's 8 oxygen times 2 times 4 is is 8, and then times -2 gives me -16. There's 2 P's because one unwritten 1 times 2 is 2, times 5 is +10, and then the V has to give me +6 to make this 16 minus 16. Since there are 3 of them in the equation, because again, this 2 only affects the thing in the parentheses, this 3 is totally separate, they are +2 each because +2 times 3 gives me the +6 that I need. Now be aware when you're doing these equations in the beginning, this is what I want to see. But as you get more advanced, or as you get better at this, or in chemical equations, you will never see these bottom numbers. They're basically doing it in their head or on a separate sheet of paper. These top numbers here, the -2, the +5, the +2, these are the numbers that matter. These are the answers. Most people don't care about these bottom numbers. There are something, you need to be aware of it, but it never gets written out. So there are some practice problems down here. You can do these. These are basically more practice from the ones that they're basically the same problems that we were doing. These they're a mix of everything we've done. There's nothing new here. I will send out a answer key for the worksheet as well, so that way you can try them and check them, and then there will be a Castle Learning assignment on this.